Hello, I'm Shrikar and I'm from Team Prometheans, and our project is to build a robotic manipulator with a vision system and is also equipped with a robotic arm. So the project will be carried out in three stages, and the first is to build a rover with a six-wheel drive platform and skid steering, and to equip the rover with a 6 degrees of freedom robotic armature, and also incorporate a vision system for object identification and for the rover to be able to navigate its surroundings. So, getting started on how the project has been carried out, stage one was the build of the rover. So, first we started by simulating the rover in our computer, and we used a ground control station to control the rover. And this is the basic structure of how the system works. Basically, the rover runs the drone kit, and the companion computer has a ground control station on it, which gives the autopilot instructions to run. So the auto this so this is how the basic simulation works. We launch a Python script. So we first install SITL and map proxy. After these two packages are installed, we run simvehicle.py, and we define the platform as a rover, and which is the platform, and we say minus minus console and map, so that we can see all the details of the rover in the console, and where the map is located on the map. And this is the GCS ground control station. We either use APM planner or mission planner to give the robot instructions and define waypoints and tell it where to go. Coming to the build and configuration of the actual rover, the autopilot is on a Pixhawk microcontroller device. We install the firmware on it, and that is the autopilot software. We have a Sabertooth 2x32, which is a two-channel 32 milliamp current motor driver, and that drives all the rover's motors. And we communicate using either a cable or RF telemetry communication. And then this is how we actually communicate with the rover, by giving it commands. So we first get raw spy here. We get so this is the first stage. We import all the packages, and then we arm the device. So arming the device basically is to say that we start all the sensors and get the motors running and everything. And here, this is where we take off. We use something called RC overrides here. Message, we're defining an object with RC overrides that basically allows us to run both channels, which is left and right channels of the steering, left and right sets of the steering simultaneously in one single thread. So that's what RC overrides does. And here, message.channels left channel, we can give a throttle value between 900 and around 1800, which is a safe value. 1500 is the middle value, which means the motors will come to a full stop. Less than 1500 would mean it would go backward. More than 1500, it would go forward. In stage two, about the robotic arm, we first make a 3D model. We first downloaded a CAD file, and using Blender, we made a URDF out of it. URDF is basically an XML file format which defines all the physical attributes and their coordinates and everything. And using MoveIt, we create a configuration package. So we use MoveIt Setup Assistant for that. For the command for that is launch MoveIt Setup Assistant. Here there are self collisions, which is basically the MoveIt Setup Assistant will detect where the points of collision can occur using the URDF coordinates. Virtual joins is connecting the rover to the physical world. And then there are planning groups, which say if it's a humanoid robot, the head, all the parts of the head would be a single group, and the arm could be another group. So basically configuring them as units. And then we have robot poses and end effectors. So this is where we basically define all the attributes, and that's then we create a configuration package, and then we start the ROS nodes. So using the MoveIt package, we send commands, and those commands are interpreted by another Python script that we run. So we take here's the publisher node, which is which is running on the MoveIt side, and the Python script interprets that data, converts those angular positions into PWM data, using module, and then that PWM data is sent using a module called I2C PWM, and that is which is another node, and that node finally publishes it to the ARM, physical ARM, and that's how the ARM is controlled. And that's the listener function is usually wrapped in the entire listener data is wrapped inside a listener function, and that's how the robot is ARM is controlled. This is RViz, which is a visualization software where we can actually see what is happening to the robot, and here we can actually adjust the angular positions and values and such. Speaking about my contributions in particular, I was involved in simulating the rover in SITL. I was also involved in the building of the rover, and then calibrating the sensors and procuring additional materials. Also, the companion computer which is on board the Jetson Nano, I was involved in setting it up, and I was also involved in the scripting process and programming the rover. Thank you.